If you guys have been watching xTool F1 Ultra videos lately, you'll likely have come across videos from people like myself who have had the privilege of accessing the F1 Ultra pre-release, and likely they're dropping a lot of these videos with generic example projects. Now I've got a video like that coming up too, but I decided to take the opportunity to make this video much more specific with a lot more technical information because I knew everybody else would just be making those generic videos. And so if you guys aren't already aware, the F1 Ultra features a 20 watt blue diode laser as well as a 20 watt fiber laser. And I think it's going to be that fiber laser that's going to be the main attraction of this machine. So I decided to make it the focus of this video. Now, rather than just show you guys the sample file that's available on the xTool website, I always try and provide you guys with more value in these videos. So I want to try and get you up and running with creating the files necessary to make these 3D embossments, because they are different than files that you would use for, let's say, engraving. They're known as depth maps, and we're going to dive into those later in this video. Now, this is my first fiber laser, but I didn't want us to be limited to example projects, downloads, or paid files. I wanted to generate my own unique designs and share with you guys the tools that you would need to make those designs for yourself as well. So let's get started. In my previous video, I did a general unboxing and setup of the F1 Ultra, but the one thing I did not cover is the calibration. During shipping, the Galvo laser system might get bumped around, and it's a really good idea to do a calibration. And to do that, the first thing you should do when you get your machine is grab the scratch paper from your material sample, tape it to the bed, and measure the thickness. If it comes up greater than 1 millimeter, so in my case I've got 3.3 millimeters, this means we need to do a calibration. We can do that by clicking on the settings of the xTool F1 Ultra and homing the Z-axis. Then we can use the up arrow on the F1 Ultra controller to move the focus up to about 0.3 to 0.5 millimeters. Then back in the settings, we'll go into parameter settings. We can click on the fiber IR and blue light laser calibration button, and then we can follow the on-screen prompts. It will first ask you to tape the scratch paper down, which we've already done. And then we can click on the Engrave button on the next screen, make sure the lid of your machine is closed, and use the green button on your touchscreen to process the job. You'll get a close-up view of the two crosshairs that were just engraved on that scratch paper, and you'll see a set of blue and red crosshairs overlaid on top of those. And you can use the plus and minus buttons to zoom in, drag over to the blue crosshairs, and find the offset. You'll see my engraved crosshairs is over just about 0.1 millimeters to the right, and also 1 millimeter down to the negative. And on the fiber IR, so the red side, I've got it just down 1 millimeter into the negative on the y-axis. Now I can remove my scratch paper, and the last thing we're going to check for here is the alignment of the blue and red dot aiming laser. If the blue and red dots don't line up, we need to make some adjustments here to the red dot aiming laser. So now I'll click on not overlapped and follow the rest of the on-screen prompts. They're all written out, but I'll walk you guys through it and give you a visual guide. You'll first remove the USB key at the back of the machine so it disables the lasers. Then you're going to lift the lid and take a peek up to the right side of the main laser lens, and this is where you'll see the red dot source. Use the hex key screwdriver that came with the machine to loosen off the screw to the left of the red laser. You only need to turn that screw 1 or 2 times, do not completely remove it. Then you can stick your screwdriver into the hole to the right of the red dot laser, and you can gently pry it in any direction to manipulate the position of the red dot laser, and you're going to want to line up the red dot with the blue dot on the laser bed, and once it's lined up, then you can retighten the screw to the left of the red dot laser. Now that we've finished the calibration, earlier in the video I mentioned that we're going to be focusing mainly on embossing, and I'm going to be using the 40mm challenge coins for these examples. I'm going to be holding them in one of my circular fixtures, and you'll see that these fixtures were originally intended for the F1 on the right hand side, and I've got an adapter available to adapt F1 fixtures to the F1 Ultra. And so you can see here I've got a brass challenge coin inside of my circular fixture mounted on the F1 Ultra, and I'm going to run a sample job from the xTool website to establish a baseline. The project comes with 2 objects, both of which have their settings already predetermined. And the first one here is just this solid red circle. And so I'm going to refresh the screen, and we're going to capture the image of the brass coin. And you can see it's nicely centered in our workspace. And the second object is an image of the lion, and that's a depth map image. In a few minutes, we're going to be talking a lot more about depth maps, but for now, just take note that the output of the lion has been disabled, and we're going to measure the thickness of our workpiece. After using the auto measure function, I always like to refresh the screen just to make sure that the image does not change at all. And now we can position the solid red circle over top of our brass coin, and we can use the framing button, the top right hand corner of the screen, to double check its position on top of the coin, and it looks good. So I'm going to stop the framing, and we're just going to go ahead and process this solid red circle, and as far as I can tell, it's just a cleanup pass for the coin. So there's really not much to see on the coin itself, so we'll just immediately hop back into Creative Space, and I'm going to take the lion and I'm going to position that in the center of the red circle, which is centered over top of the coin. We'll enable the output of the lion, we'll disable the output of the red circle, and here you can see the settings. So they've got the power set to 100%, the speed set to 1000 millimeters per second, and we're using the IR fiber laser. I'll send this job over to the F1 Ultra over Wi-Fi. And if you guys need more information on using xTool Creative Space 2.0, I've done a video about that in the past. I'll put a link to that in the top right hand corner of the screen right now. And that was done on the xTool P2, but all of the general concepts are the same, other than, of course, this new amazing embossing feature, which is limited to the F1 Ultra as far as I can tell. Now, although this example looks pretty interesting, something did seem a little off to me. The surface finish was not what I had expected from a solid brass coin. And so I started to suspect that the materials that I got here were not brass at all. Perhaps they have a brass plating on the outside, but solid brass should not be magnetic. So one way to check your materials is just bring a magnet close to this coin, and you can see here that the inside is probably steel. So that's pretty disappointing, but it's a lesson learned that we should be getting our materials from a trusted source. Once I got my hands on some real brass coins, and I'll put a link to those in the video description down below, I reran the exact same job with the exact same settings, and this is the result. The brass has a much more consistent and uniform appearance all the way through from the top to the bottom, and that's because it's one homogeneous material. There wasn't a plating on top of something like the last coins, which were just plated steel. The result is a little bit dark, so we're going to bring back the brightness of the original brass. So I put the coin back into the F1 Ultra, and now we're going to rerun the cleanup pass with that solid red circle. In the project file from xTool, technically it's actually 3 passes, and you can see how with each pass, the coin progressively gets brighter. It's an extremely noticeable difference, and when you put it side by side with the fake brass coins, you can see that it's worth paying the price for the real material. The fiber laser is very effective at removing the material from the brass coin, but just keep in mind that this material does have to go somewhere. The fan at the back of the F1 Ultra does a nice job of drawing in those waste materials, and you can see the accumulation of brass particles in just one coin. This keeps the material down and away from accumulating on the lens. However, I'm hoping that in the long run, it doesn't gum up the fan and affect its performance. I've been working on a pre-filter solution for that fan, and when it's ready, you'll find links to that in the video description down below and on my website, embracemaking.com. Now, as good as that fan is, it's inevitable that some of those particles will become airborne and will escape the enclosure of the F1 Ultra. If you're doing a lot of embossing, you might want to consider investing in some kind of a tent. This one has a provision for an exhaust port at the back, as well as a cover that zips up in the front. This will help contain anything that escapes the enclosure and will make cleanup really easy, where you can just wipe it up with a wet cloth. If you guys are interested in an enclosure like this one, I'll put a link to that down in the video description as well. Now that we've taken care of the air in and around the machine, what about the exhaust coming out of the back? The material removed from these workpieces needs to go somewhere, and if you're getting workpieces from an unknown source, who knows what's in there? And so that's why we need to set up a proper ventilation system. You don't want to be breathing in small metallic particles or other unknown materials. And you can see in this clip, I'm using one of my hose adapters to adapt the xTool F1 Ultra hose to a more standardized 4-inch or 100mm duct hose. Then you can use a 4-inch inline duct fan like this one, which features a speed controller, and you can use that to push the exhaust fumes outside of your home or workspace. I'll put a link to this model in the video description down below. xTool also offers a 6-inch duct version, and they include the 4-inch adapters. You can see that I've got mine routed outside of a custom panel that I set up in my basement window. And if you can't get the smoke and fumes outside, xTool also offers a filtration system. I'll put a link to that in the video description down below as well as a link to an air quality sensor monitor so you guys can keep track of the air quality in your workspace. So I can show you guys examples all day long. If you got an F1 Ultra or you're considering one and you want to do custom 3D embossing, then you guys need to know about depth maps. I believe they're also known as height maps, and the concept here is that you have a grayscale image where we're going to try and map 3D information into a 2D image using shades of gray. And on this 2D image, the things that are very close to you are going to be represented by shades of white, and the things that are very far away from you are going to be black or dark gray, and things in the middle will be those medium shades of gray. There should be 255 values, 0 being black, 255 being white. And so if you open up the histogram here of the lion example in Photoshop, you can see in the histogram that in the middle, you've got a large cluster of pixels that would be in the gray region. On the left, you got a peak of black, and that would be the background. On the far right hand side, there's maybe a tiny bit of white. And I'm just playing around a little bit with the level sliders because your eyes may not be able to easily differentiate between all the different shades of white or gray or even black. But all of this information is packed away into this 2D image, and this is how the xTool Creative Space software knows how to modulate the fiber laser in order to emboss lighter or deeper into your material. So now that we know what it is, I want to show you guys different ways of making them or generating them so that you can achieve your own creative designs. And the first way to do this is to start with a 3D model. And if you're not at the point where you can make 3D models yourself, you can always hop onto Google and search for free 3D models. There's tons of them, and you're going to want to try and find something in an STL file format. I found this one here. It's already in the shape of a coin, and if you're doing embossing, you're probably going to want to use keywords such as embossing or even wood carving. Now, if you're a more advanced user, you probably already know that you can get depth maps from more complicated programs like Blender, or you can use tools that automate the process for you. I'll put a link to this one in the video description down below, where with just a few settings, you can upload your model and it will spit out a depth map for you. Now just bear in mind, with very few adjustments that you can make on this website, you may or may not get the desired result. But for almost zero effort, that's a pretty good starting point. I'll save that image to my computer, and these depth maps should be in PNG format. I'll open it in Photoshop, and again, I'll take a look at the histogram, and you can see here that there's a nice distribution of different shades of gray, everything from black to white. And again, when you go ahead and play with those level sliders, you can see some of that information start to reveal itself. I can't stress enough that what you see with your eyes just on the surface is not giving you the full picture of all of the information that is packed inside of this 2D image. That being said, if you do know what you're doing inside of Photoshop or another graphics editing program, you can manipulate the depth map to get more depth or more range inside of your image. But for this example, I'm going to just leave it as is, and I'm going to crop out the black background because all I want is the circular image here. I'm going to be embossing it on a circular coin. The process of saving your image is also quite important. You do not want to lose information or have your program add any unwanted information. So for me in Photoshop, I like using export, quick export as PNG. I find that this method maintains the original integrity of the image. Conversely, I would not recommend using export as there are options in here to change it to a smaller file size, which will likely clip information or resample some of the details inside of this image. Now I can hop back into xTool Creative Space, and I'll be repurposing the solid circle from the lion project, and I'll just be cleaning up the surface of the next coin that we're going to emboss. Once that's done, I can bring in the new depth map, and I'm going to resize it appropriately for the coin. I'll enable its output, and just don't forget to disable the output of that solid circle. For this graphic, I'll be using the exact same settings as we did with the sample lion. So I'll be switching over to the fiber IR laser, setting the power to 100%, the speed to 1000, and leaving all of the other parameters at the default settings. And so the reason I left all of the settings exactly the same was for consistency, so I could compare this result to the previous result with the sample project from xTool, which was that lion. And I'd say that the results are pretty close. The lion does look slightly more 3D, and I think that's because it had a solid black background, so there was a lot more depth to that design, whereas this one was more in those medium shades of gray. But ultimately, the purpose of this example is to show you one type of workflow to go from a 3D STL model to a depth map and then get a nice embossed result using the xTool F1 Ultra. Now what happens if you can't find or generate a 3D model, but you still want to do an embossing? Well, perhaps you're good with 2D graphics, or for better or worse, you want to use AI generated 2D images. As you would imagine, this is entirely possible, and there are some things to watch out for to get the best possible depth map for that embossing. I'm going to be using Adobe Firefly to generate the original images, and there are tons of other free AI image generators out there. Even xTool Creative Space 2.0 has an AI image generator built into it. For these images here, I've used the following prompt: circular coin with pirate skull, wood carving, mythical theme, neutral colors, neutral lighting, orthographic. We're trying to ideally generate images that do not have heavy highlights or shadows coming from one side or corner of the image. To get depth maps from these images, we're once again going to lean on AI for a little bit of help. In the video description down below, I'll put links to various AI models that are somehow able to interpret these 2D images and spit out a depth map. So in some regard, they're kind of doing what our brains are doing, and they're looking at the highlights and shadows of these images, and they're able to assess the subject matter and figure out which features should be set into the background and which should be pushed to the foreground to give us this depth. I'm specifically going to link to AI models that can be run directly in your internet browser, so they're super easy to use. You just upload the image and it will save the output to your downloads folder. Now, another one is this website called DepthR, and this one is the same concept where you upload your 2D image, you click on Generate Depth Map. However, this one has some more controls where you can increase and decrease the height, the depth, and there's a few other things you can select there, like denoise, remove background, blur, etc. This obviously gives you a little more control over the output, and you can see the preview on the right hand side. And when you find something that you're happy with, you can just export this and save it locally to your computer as a PNG file. Each of these services is going to interpret the image differently, so you're going to get a different result. So you may want to try all three and cycle through them to see which one is the best. But then the question becomes, how do you know which one is the best when it's pretty tricky for our eyes to figure out what's going on in these depth maps? I would suggest that you download this program called Materialize. It's absolutely free and it's fairly easy to use. When you first open it, you'll see a blank slate, and you'll want to click the little O button in the diffuse map panel, and then open your 2D flat image. And then to the left of that, there's a box that says height map. There's also a small O button. O stands for open. And then with that one, you'll open one of the depth maps that you just generated using those AI services that I showed you. Then you can click on the show full material button, and the program will use the depth map information, and it will deform the original 2D image to show you the 3D result. And if you go back into the height map box in the top left hand corner and you click the O button again, you can open up a different depth map, click on show full material, and this is how you can compare the results. As I mentioned earlier, each of those AI models will have its own unique interpretation of the 2D image. So that's why I find it very useful to do this as a sanity check, just to make sure that no unwanted feature has been brought up to the foreground, or you don't have any weird spikes or bumps in your depth map. For this example image, all three results were pretty good, and if you zoom way in, you can actually see some of the 3D details inside of the pattern beside the skull as well. But the thing I was most disappointed with all of these models was that the skull looked a little bit flat. It did have some depth to it, but the forehead region just wasn't really round. So I'll press the small C button in the height map box up in the top left hand corner to clear the existing depth map, and then I can click on the create button in that height map box, and this is going to bring up a control panel with a bunch of sliders where you can create a depth map from the diffuse image. Now there are some built-in preset buttons, but you can also use these sliders to gain a lot more resolution into the output of your height map. Now the user interface is a little bit lacking when it comes to describing what each of those buttons and sliders does. So you will have to play around with them a little bit and get some seat time in this program if this is something that you want to explore. If you are going to be creating your own unique designs, I would definitely keep this program in your back pocket as a very useful tool, as it's completely free and it even has some more advanced features like being able to choose colors from your 2D image and isolating those colors and manipulating them. This is particularly useful if, let's say, you had a lighter color in your image that would normally get interpreted as being in the foreground because it's light and bright, and you want to isolate that and push it to the background. Eventually, when you're done messing around with the depth map, you can just click the button in the control panel there, set as height map, and then you can click on the button that I showed you earlier, show full material, and you can preview the result. Now in this case, I didn't do a very good job. You can see the nose of the skeleton is sunk in pretty low, so I would have to go back and edit that depth map. Another thing you can do in this program is you can actually edit the 2D image, so that's what's known as the diffuse map. So in that panel, you can click on edit, and again, you'll get a control panel with a bunch of sliders where you can manipulate your 2D image. In the original 2D image, there might be areas that are causing problems for you, such as hotspots or dark shadows, and you can pull those in and out and flatten your image a little bit so that it is even more neutral than what the AI image generation model had output. Once you're happy with the changes you made, you can set that new image as your diffuse map and then build a height map or depth map off of this new image. Once you've found a depth map that you're happy with, there's a box titled Saving Options. You can just click on PNG to make sure that any output is saved in PNG format. You can go over to the height map box in the top left hand corner, click the little S button, S stands for save. You can save that output to your computer, and now you have a height map generated with Materialize. As with a lot of things these days, you do get what you paid for, and while free is good, sometimes paid is better, and I did find this paid software called Vista Sculpt, and it can help us very easily generate depth maps from 2D images, and you can download a trial version of the software, and you can play around with that, but you will have to pay to export any depth maps. The reason I really like this software is that it has just enough control that it's not overwhelming and has the exact tools that you need in order to get a good output. And the AI model that it's using to interpret the 2D images tends to produce high quality results that just make sense. And when I say make sense, I mean that the 3D output of this program seems to align with the way my brain is interpreting the 2D image. So for example, in this skull coin here, you can see that the skull, which is the main focal point of this design, the software was able to figure that out and really bring it to the foreground. Some of the free AI models that I showed you guys earlier did a pretty decent job, but in my opinion, none of them did quite as good of a job as this software here. And the benefit of this one is that you are getting a 3D model output, so you can make adjustments to the scale, so you can scale in the X, Y, and Z direction, and you can directly manipulate the mesh. So there are brushes, and you can adjust the brush strength, brush size, and using the brush, you can add or subtract material on the 3D model. So in this case here, you can see that I can bring up the nose area of the skull, or if I want the forehead more round, I can manipulate that area as well. When you're only working with the 2D image, like I showed you guys in previous examples, this kind of thing is really difficult to do where you're just targeting very specific areas of the image. You'd have to bring your original image or even the height map output into a program like Photoshop and then manipulate those sections of the 2D image afterwards. Now I will touch on that in a few minutes, but I just want to reiterate that this program here I think is targeted to people who are not 3D modeling experts, but you just really want to get up and running very quickly with making 3D designs. If you're already an expert in this field, then you'll already have access to much more powerful tools, but likely those have a much steeper learning curve. In VistaSculpt, in a matter of minutes, you can generate your 3D model, and you can do some simple things like part your model using a plane, and even solidify and close the model, as well as applying textures to the surface. And when you're done, you just simply click on Export 3D, and you can choose to export your model as a 3D STL or as a 2D PNG depth map. And just as I had finished editing this video, VistaSculpt released a new version of their software. Now you can create AI generated images right inside of their software. So essentially you can condense this entire workflow into this single program. Just started playing around with this version and have only generated a limited number of images, but it does seem to do a pretty good job. I'm not sure if it's already including certain prompts in the background to ensure that the output is giving you something that will translate really well into a 3D model, but this is kind of the entire premise of the software, so I wouldn't be surprised. It also allows you to now build a frame around your 3D model. Now this might be a little more geared towards the CNC crowd, but perhaps this is useful if there's some overlap in your interests and hobbies. So again, this is a paid software, but it does seem to be receiving frequent updates with new features being rolled out. Now, if you are on a tight budget, that is obviously understandable. So we can have a look at post-processing some of these depth maps that perhaps you created in a free software and they need a little bit more work. Now I'm going to be using Photoshop, but of course there are free programs just like Photoshop where you can use the same concepts that I'm going to apply here to the depth maps. In your editing program, you're going to want to have your histogram open. We talked about what that was earlier, essentially the distribution of white, gray, and black pixels in your image. And I also like to have open a few other sample images, which turned out well for me in the past. It's always nice to have some kind of reference material on hand. Now every image is going to be different, so it's not like there's going to be a rigid 5-step process that you can follow. I'll just show you some tools here that most programs will have and their effect. So brightness and contrast is one thing that you can adjust, and nearly every single graphic editing program will have this. Now brightness is obviously going to shift your distribution of pixels up towards the white, and by increasing the contrast, it's going to actually spread them apart. It's going to make the darker tones darker and the lighter ones lighter. And if you notice in the histogram, as I increased the contrast, it actually created gaps or bands of empty information in my histogram. So I'm not an expert in this matter, but it would seem to me like Photoshop is not creating new information, it's just taking the existing information and sort of pulling it apart. Now in practice, when you go to emboss something like this, it's not that deep, so you probably won't notice, but if you have those gaps, you might not have as smooth of a transition between the various heights. And again, you probably won't notice it. Alternatively, another tool you can use is the levels adjustment. In here, you can play around with the input and output levels. So again, you can look at your histogram and you can shift some of your shades, make the blacks blacker, make the whites whiter, but you can also change the output levels, and in there you can actually clip information. So you have to be careful about using the levels tool. My general approach in post-processing is to preserve the information in the depth map and not to actually clip any of that. When I'm making these adjustments, I'm paying some attention to the image itself, but probably a lot more attention to the histogram and trying to figure out the impact of these adjustments on the end product itself. For example, if I use one of the input sliders to clip some of the darkest or blackest shades of my image, then essentially what I'm doing is I'm bringing up the floor of that 3D embossing and chopping off the bottom. Now, if you're looking to target very specific shades inside your image, you can use the curves adjustment, and you can add inflection points to the curves spline, and this can help you target specific areas of gray, black, or white. So for example, if I know that the skull is mostly made up of white pixels because it's in the foreground, I might want to target the white regions and make them more white to try and bring them even more to the foreground. Now there's definitely going to be some trial and error in all of these processes, but I just want to give you guys some tools to work with here for you to play around with and experiment with. Now up until this point, all of the adjustments that we've made have been to the image as a whole, but don't forget you can also use selection tools. So you can manually draw selections over your image or even automatically using tools like the magic wand. And then you can make those adjustments to just those areas of the image. I personally find this to be the most useful thing. So in this skull coin, for example, these sunken regions in the background of the coin, if I want them to sink further into the background to add a little more depth, I can select those regions, and then I can use perhaps brightness and contrast, and I can just bring the brightness of those regions down, and that should make them deeper in the actual physical coin. Now, if you're going to use this method, the other thing I would suggest is looking into whether or not your program has options for manipulating the selection itself. So for example, in Photoshop, we can feather the selection, and this is effectively going to smooth out the transition between the areas that I adjusted and the areas that I did not. Now in the physical embossing, this will also do the same thing in 3D space. It's going to smooth out those transitions so you don't have an abrupt change in depth. Personally, I find this method most useful for selecting subjects in the foreground, like the skull, and then in the embossing, trying to bump them up just a little higher to bring them forwards more. Now just keep in mind when you're doing this, you can see up in the top right-hand corner, while I have the skull selected, in the top right-hand corner, the histogram is showing the information just for the skull. And then if I go into hue and saturation, there's a lightness slider, which I've read maintains the difference between the shades a little better than making adjustments in, let's say, brightness. But I can bump that skull up into the foreground a little more by increasing the lightness, or bringing it down towards the background by decreasing it. Just make sure if you're trying to bump it up, you're not going past the whitest white where you'll be clipping information. And finally, one of the other cool things that you can do with your selection is just to copy it and paste it onto a black background, or perhaps you've already generated some sort of 3D texture that you want to put your subject onto. And then you can again adjust the lightness to bring it to the foreground more, and you'll have a result that kind of looks like the xTool lion example. You may just have to do a little bit of work feathering the edges of your subject to better transition into the black background. Once you're done editing, or perhaps even during the editing process, you need a little bit of help visualizing what you've done. I like to use this little trick here in Photoshop. So what I can do is add a solid color layer, and I'll just select a nice bright color like red. Then I can right click on that layer and go into blending options. And in blending, there is the underlying layer, and I can drag the slider from the white down, and that's going to start to reveal the information, starting with the white shades, heading into gray, and then finally into black. And this helps me visualize my image like a bunch of layers stacked on top of one another. If you guys are familiar with 3D printing, it's kind of like the slicer in a 3D printer, which breaks up your model into individual layers, and then you can kind of scroll through them and visualize what's happening on each layer. So in this case in Photoshop, it's kind of the same thing, where Photoshop is allowing me to see each of the 256 shades of gray individually. I find this useful for identifying areas of my image that perhaps are not at the correct level. So for example, you can see right now the top of the coin has not yet appeared, whereas the bottom does appear. And so that tells me the top of the coin is deeper than the bottom. To remedy that, perhaps I can use one of the solutions that I showed you earlier, where I could select that region of the image and bump up its lightness. So hopefully that introduces you guys to some general concepts to manipulating these images in your editing software. When you're done editing and you put in all of that hard work, just be mindful of how you save the images. I very briefly touched on this earlier in the video, but if you go into File and then Export, because we want to export this as a PNG file, you have a few options. There's Quick Export and Export As. You do not want to be using Export As. There are options in here like converting to a smaller file size, or even resampling the color, and this is likely going to have unintended consequences to the information inside of your depth map. For example, if I save it as a smaller file, it's likely trying to apply some sort of compression, and then when I open that, you can see in the histogram there's a bunch of the black information in the histogram that's now missing. Now, this is fairly Photoshop specific, but I do like to just stick with File, Export, Quick Export as PNG, and then when I open that, you can see that the histogram is identical to the original. No information was lost or added, so this has been my go-to way of saving these files. Now for the fun stuff, where I show you guys a bunch of examples. So the first one here was a 2D image that I had generated with Adobe Firefly. I brought that into the VistaSculpt software, and this was the result. I output the depth map directly from VistaSculpt and imported that into xTool Creative Space, and I took a basic shape, so a circle, And what we can do here in Creative Space is select both the circle and the square image in the object list and click on Create Mask. And right inside of xTool Creative Space, we can now crop the square image using that circle. I really like making this mask in xTool Creative Space and cropping it here because you can change it at any time by clicking on Edit Mask in the bottom right-hand corner. Plus, there's no risk of loss or addition of information in a graphics editing software when saving a file like this after cropping it, like we had talked about in the previous chapter of this video. Now I'm just going to take the image and I'm going to center it over top of the coin. I'm also going to take the solid circle that represents the cleanup pass and center that over the coin, run the cleanup pass, turn the output off on that solid circle, turn the output back on our image. You can see under the processing type, I've got emboss selected, and under the settings, I'll go to user defined settings. I'll make sure the fiber IR laser is selected, set that to 100% power, set the speed to 1000 millimeters per second, lines per centimeter 300. And these are all of the exact same settings from all of the previous examples that we've done in this video so far. Depending on the depth and complexity of the image, these coins can take anywhere from 1 to 2 hours of processing time, at least from my experience. And after the main embossing is complete, I always run the cleanup cycle immediately after. And this process is very quick, takes usually less than a minute. I never get tired of seeing the fiber laser clean up the brass and brighten it. It's one of those oddly satisfying things. When that process is all said and done, the final result looks fantastic. The Spartan soldier really pops out of this design, and one thing that I noticed is that designs that have black space, so you'll see the flat space beside the Spartan's face, these ones tend to turn out the best in my opinion. Having some dead space around the main subject really makes it pop. Conversely, I have a design like this, which went through the exact same workflow, so I generated this 2D image in Adobe Firefly, brought it into VistaSculpt, which I thought did an excellent job interpreting what that would look like as a 3D model, considering all of those crazy details. But despite that, what you'll notice with this design is that the main subject, so the pirate skull in the middle, doesn't seem to pop out quite as much as that Spartan. There's just less of an elevation difference between the front of that skull and the other skulls in the background behind it. However, maybe that's the look that you're going for, and in this case, all of those insanely small details inside of the pirate hat came out looking flawless. And equally as impressive, all of the details in the smaller skulls was also maintained. Now don't forget that even once you do the embossing, this doesn't mean that you can't go back and add some more details with the Engrave feature. So I've brought the original image back into xTool Creative Space, and I've placed the coin back on the laser bed. Now, ideally, you shouldn't move the coin. It's much easier to line things up. So I had to spend a little extra time making sure that the image would line up with the coin. Once I was happy with the placement, I switched over to Process on Flat Surface so that we could access the Engrave feature instead of using the Emboss. And then in the Material Easy Set library, I'm going to go ahead and select the blank commemorative coins. The image that I'm working with is a raster image, so I'm going to select Bitmap Image Engrave. It's not a vector. Click on Open in xTool Creative Space, and you can see the image has now inherited those properties from the Material Easy Set library. At the time of the making this video, the F1 Ultra is still so new that in the Easy Set material library, it seems like there's not as large of a range of settings as there are with some of the other more established machines. So I went ahead and took that 95% power and dialed it down to 80% because I thought it was just too much. Then I'm going to make some adjustments to the image, and you'll see that I'm going to clip a bunch of the lighter shades of gray. And then what's ever left in the black range, I'm going to bump that up a little bit, and you'll see that the image looks a little washed out, but that's what I'm after. So I've got a lot of the deep shadows, and I just want to engrave those back onto the coin. The effect that I'm going for here is the illusion of more depth. So I'm kind of coloring the shadows back onto the coin because in my opinion, the embossment result just looked a little too visually flat. And you can see here now that the coin looks a lot more like the original image. And depending on how you look at it, you can still see that it's got depth to it because of course we embossed it. This next coin was another AI generated image. I'm going to be using the same settings as all of the other coins, and I'm going to cut out most of the workflow since now you guys know from the previous examples what I've generally been doing here. And in this design, I requested a Zeus-like Greek god character. You can see that it gave me a pretty classic looking bearded godlike man. This design has a bit more negative space around the main subject's head, so it should pop out a little more than that last design, and I think it does. I'm always impressed with the amount of detail that's retained in features like his hair and his beard, even the wrinkles in his forehead if you look close enough. Now with this one, I'm also going to experiment a little bit with engraving on top of it. So I've grabbed the original image and go through the same workflow as I did with the pirate skull coin. Now with the pirate skull coin, I thought that the engraving turned out a little too dark for my liking, even though I dialed back the power setting. Therefore, for the Zeus coin, I'm going to dial back the power even more. This time, I'm going to set it to 70%. And if you guys are trying out the engraving after embossing, don't forget to make those adjustments to the image. A few times I caught myself pressing the process button a little too quickly. And if you had processed the image before making the adjustments, I feel like it would just muddy the embossing a little bit by engraving too many details on top. I really think by engraving only the deepest and darkest shadows, you get the most contrast out of the design, and that looks the best. Overall, I think this one turned out pretty nice. I didn't blacken the brass as much as the pirate skull coin, so I think in the future I would use 75% power on the engraving setting. And finally on this last coin, I'll skip the entire workflow in xTool Creative Space since it's exactly the same as all of the previous examples, and I've got this incredible looking dragon design. And yes, you guessed it, I also generated this image with AI and created the 3D model using VistaSculpt. That tool is just so efficient and effective. This one here I really like. I don't think it needs any engraving on top. You can even see the tiny scales on that dragon. All of the details are extremely well preserved, and I think it's between this one and the Spartan Soldier that are my favorite. The last thing that I've got for you guys is that I've noticed in xTool Creative Space, there doesn't seem to be the equivalent of a material test card for embossing. So I created this grayscale wheel with these discrete sections, and you can see in each section the percentage of gray. Obviously white is 0% and the white text is pure white, so that'll be at the top level of the 256 layers. And you can go ahead and process this on any kind of material that you're looking to test out. Now I just processed this example on a brass coin with the settings that I knew would work out, and you can see the difference in depth in each of those sections. The concept here is that given a certain power setting that you've input into xTool Creative Space, you can visualize the highest and lowest point on your material and various steps in between. I'll make this file available for free in the resources section of my website, embracemaking.com. So that's it for this video. Thanks for sticking with me right to the end. Hope you guys can appreciate the level of detail I've tried to go into in this video, not just showing you guys the settings in xTool Creative Space, but instead trying to present you with various methods to creating your own 3D embossment designs. And there's always more than one way to accomplish something, so I'd love to hear from you guys down in the comment section how you would go about doing this. And if you guys plan on producing your own commemorative coins, I've also designed these coin holders that you'll find on my website. Link in the video description down below. They're made of plastic and the base can be engraved with an IR laser, such as the one on the xTool F1 Ultra. So go check those out, as I think it's a great way to display your own collection, or perhaps even provide a solution for your customers. And don't forget to subscribe for more in-depth content like this in the future. I've got a lot more xTool F1 Ultra videos on the way.